It was mentioned that different places of the basilar membrane perceive different sound frequencies. Critical band is nothing else but a set of these frequencies on the basilar membrane which are perceived as the same pitch or frequency. If we take a look at this picture that shows the frequency on the x-axis and the critical bandwidth at the y-axis, we see that from around 100 Hz up to 5 kHz, the width of the critical bands, they remain practically constant. At above that frequency, the critical bandwidth increases a little slower than in proportion to the frequency, and for frequencies above about 3 kHz, a little faster. It's useful to assume a constant bandwidth of 100 Hz up to 500 Hz and a relative bandwidth of 20% for center frequencies above 500 Hz. The critical band concept is important for describing hearing sensations. It is used in many models and hypotheses that a unit was defined, leading to the so-called critical band rate scale. This scale is based on the fact that our hearing system analyzes a broad spectrum into parts that correspond to critical bands, adding one critical band to the next in such a way that the upper limit of the lower critical band corresponds to the lower limit of the next higher critical band. And this leads to the scale of critical band rate. So we see that the spectral effects have higher influence on the bandwidth. So the bandwidth of the signal plays an important role, and the sound level also influences the loudness level. So the total sound intensity, sound pressure level, have to be constant to measure loudness as a function of bandwidth. As we mentioned before, these critical bands, they can produce a scale that is called the critical band rate scale or the BARC scale. It grows from 0 to 24 and has the unit BARC in memory of Backhausen, a scientist who introduced the phone. That is a value describing loudness level for which the critical band plays an important role. The relation between critical band rate Z and frequency F is important for understanding many characteristics of human ear. The critical band rate is closely related to several other scales that describe characteristics of the hearing system. We can attempt to approximate the critical bands with formulas. So here is one formula for the critical band rate Z, and here a formula for the critical bandwidth. So here we can have a relation between Z and F, and we have the Z as the critical band rate. We have lower and upper frequencies. So BARC 0, the unit 0, goes from 0 to 100 Hz. It's centered at 50 Hz and has a delta of 100 Hz. So we see we go up in the number of BARCs, and we see a different changing in relation, but up to 3 bar, this delta remains constant here. The center frequency is increasing by 100 Hz up until BARC equals to 4, and then we start noticing difference in changes.